Hey, welcome. Today, we're going to go on this really cool journey to uncover a kind of hidden code. It's this surprisingly simple but incredibly powerful language that people have used for thousands of years to describe, to build, and to understand the world all around us. And you know what? It all starts with one fundamental question.
How do we actually make sense of physical space? I mean, think about it. Whether you're trying to figure out how much paint you need for a wall, or how many books you can cram into a box, humanity has always needed a way to measure and define the world.
And really, when you get right down to it, each of these questions about size and shape and space, it's just a little puzzle. They're just everyday problems that are waiting for a clever solution.
And here's the best part. The key to solving them isn't some complex, intimidating math. Nope. At the heart of it all is a really simple, kind of elegant language, a code that lets us translate our physical world into numbers we can actually work with.
So what is this code, what does it actually look like? Well, we can break it down into two basic parts. And instead of thinking about them as dry math terms, let's just think of them as sentences and puzzles.
Okay, and I really love this way of looking at it. On one side, you have math sentences. The official name is expressions. They just describe a situation, like length times width. That's it. Then on the other side, you've got math puzzles, or what we call equations. They use those sentences to ask a question, like, so what is the area?
All right, enough talk. Let's actually see this code in action. We're going to solve a few really quick, satisfying little puzzles for area and volume. This is where it's all going to click.
First up, puzzle number 1. We've got a triangle. Its base is 5 and its height is 10. To solve this puzzle, we just need to use its math sentence.
So we just plug our numbers into the formula. That's 1/2 times 5 times 10, which gives us,
Boom, 25 square units. Simple as that.
Okay, let's keep the momentum going. Next puzzle, a rectangle with a length of 6 and a width of 4. The sentence here is even simpler, just length times width.
So we just multiply 6 by 4 to get our answer, which is 24 square units. See the pattern now? A sentence describes the problem, and we use it to solve the puzzle. It's pretty neat. All right, for our final puzzle, let's level up and jump into 3D. Imagine a box with a length of 3, a width of 2, and a height of 5. And guess what? The code expands perfectly to handle this.
The sentence is now volume equals length times width times height. So we multiply 3 by 2 by 5, and we get
30 cubic units. And that right there is the crucial point. This simple code works just as well for flat 2D shapes as it does for 3D space.
Now, we've solved some simple puzzles, right? But what if I told you this wasn't just some classroom exercise? What if this exact same code is part of an ancient blueprint?
Seriously, take a look at this. This verse from Genesis isn't just a story. It's a set of precise instructions. It's an ancient formula that describes the exact dimensions of a massive structure: length, breadth, which is just another word for width, and height.
This is the exact same logic we just used to find the volume of that little box, but it's being applied on an absolutely epic scale. It shows us that these formulas, these simple math sentences, are nothing less than an ancient blueprint for building our world.
So when you step back and really look at it, the power packed inside a simple formula is actually pretty profound.
I mean, think about what we just saw. This hidden code can describe the simplest little shapes and calculate their area and volume, but it can also scale up to provide the exact instructions needed for these massive structures. It's a direct link, a shared language that connects us to builders from thousands of years ago.
So that leaves us with one final question. If this simple code can describe a cardboard box and an ancient ark, what else in your world can it help you understand? Once you start looking for it, you might be surprised by what you find.